So here we have the parts printed now that are going to make the helping hand. So these parts are not printed, although you can 3D print these. I have seen models on Thingeverse. So these are standard flexible fluid arms. I'll try and put a link on the screen where I found them, but they're readily available. So there's going to be 4 of them. The alligator clips, I was really lucky that when I popped off the orange tops, mine actually just pressed in. So this black section presses in that hole. I did have to just slightly open up those to make them press in tighter, but if you can 3D print the base, you could always 3D print yourself a reducing bush for your alligator clips to go into. So then I've got a few test pieces here which are going to be in the file download. Now these are important. I've never printed threads before, so you don't want to go printing a long print like this because it takes hours. So in the STL file there'll be test print. So what you can do is test print these little bits first to make sure that the parts screw together. They don't have to be excellent fit, but that's quite a good fit. I think I got the tolerances right for my printer, but it depends how your printer is tuned. So that's that one. And then with the holes for the cap head screws, I wanted it tight enough so you can thread these in by hand. So that test print there is too thin. I'm not sure what happened to that one. That one works, and I think that was my final test. So yeah, I've screwed that in already. So the idea is that these won't drop in, but the smaller bore is just good enough to grip on those. So if you upended the tray, then all these aren't going to fall out, because that's the worst thing you want to do. I didn't want to thread all the little holes because it would take a long time to print, I'd have thought, and there's no need. Once these are in, they're not coming out. So how did I go about designing this? Well, this will fit on a standard ender bed. I could have made it bigger. It was too big to print on my Ultimaker 2, so this was my first print on my 5 Plus, so the bed is massive for that, but I kept this design. I put the dimensions on the screen. That will fit on a standard ender. I've actually got a ruler here, so that way it's 215mm or 8.5 inches. That way just under 11.5 inches or just under 290mm. So that's the standard size. Can't remember how long it prints, but I tried to remember put on the screen. So there's lots of different designs I saw on the web about these things, but hey, I can do designs myself. There's no need to copy anybody else's. So I just wanted 3 trays for parts. The only mistake I made, and this was the first print in this orange, it's from G3D, I'll put it on the screen. It is quite a translucent filament, so when you hold it up, these bottoms could have done with a couple more layers because they are see-through. I mean, they're strong enough and it will do fine for what the job is, but there, if you can just see here, you can just see the infill coming through. So a couple more layers would have done away with that, but it depends what filament you're printing it in. So what I've got to do now is screw in, I know there's more than 100. I've got 100 of these screws. The rest are in the bag here. And I've got another bag, but for the life of me, I can't find it. So what I'm going to do, I'm going to start screwing these in. Now you can screw them in by hand. Now where's my torque wrench? So you can screw these in by hand and it takes no effort at all. So if you just, oh, it's the wrong way. But obviously doing it this way is going to take quite a long time. So what I'm going to do, I'm going to go and find my battery drill. I'm going to set the torque setting down to very low. And I'm going to screw in these 100 screws. Yes, there's going to be some holes short. So I can't remember how many holes there are now. And I'm not going to count them. These screws are normally bought in hundreds or 50s. So I bought 2 lots of 100. Because as I was designing this, I wasn't thinking about how many screws. I did it to make it look pretty, really. So the idea of the bolts is to make the base heavy. So when you've got your arms on, it's not going to move, and obviously that way you can have the arms tilting outwards, and whatever weight you've got on your arms isn't going to make the base move. So yeah, before I've putting these in, I degreased them in washing up liquid, and then I used clove laundry soap, and it's removed any grease off these. Now these could rust over time, I don't know, but it's an indoor environment, so they're never going to get wet. So you know, they are, I don't know what this coating is, but it's a black, it's not anodizing, but it's a black chemical etch on the steel bowl, so they shouldn't rust. So let me go and find my electrical screwdriver. I'll get some of these screwed in and then I'll come back. So it's the next morning and it's still printing, so we're almost finishing, as it's just doing the top part of the pockets for the bolts. So I'd imagine, oh, must be another 2 or 3 millimeters to go, but a little bit of stringing. Wow, yeah, seeing that is my first long print, I have to be happy. The top part should have ironing turned on, so it's going to be a little while longer. The machine is saying it's at 78% complete, so a couple of hours to go, I'd imagine. So here we are, the part is finished, the plate is just cooling down, and once it's cooled down we'll take it off and see how well the bolts and large shredded plastic arms fit in. But yeah, it was 24 hours, it did say 24 hours, and it has been 24 hours, that's good. That's really interesting. You can see the part releasing, the temperature's down at 41 now, and you can see it here, it's releasing. How cool is that? Glad I captured that. I wonder where we get a crack. That just shows you the bed adhesion. So it's still at 41 degrees. Once that's all gone, you can see it. 40 degrees. So it's taken 1 day, 1 hour, 15 minutes. Let's see whether it lifts up. Not quite yet. But that was quite interesting. Let it cool down a little bit more. But yeah, I've never seen that before. Maybe because this filament is slightly translucent. You saw that because you could actually see, you can see the black FR4 through here. And this is the GST 3D fluorescent orange, I believe this one is. So we're now down at 39, but it's still be, oh no, it's off. There you are. Let's turn it over and have a look. That is silky smooth. So you can see, definitely now, you can see the black through. If I hold it up to the light here, not sure whether the camera's going to focus on that. Having a hard job focusing on that. But yeah, you can see through. but the top layer, you know, in normal operation, it'll be fine. So I just hope all my cap head screws will fit in, and hopefully the threads are correct. Very happy. So it was GST 3D fluorescent orange, this paint. So I've got my drill driver, put it on the lowest torque set, and I hope it's not going to be too strong. Just going to put that in there, so I can do a bit more torque on that. Now everyone's torque driver is going to be different. Take that down. Also, while I was away, I've been working on a ESP8266 project. Also, you can use it on Arduino. It's an 8 temperature sensor data logger, and the reason I wanted that is I wanted to do some, what I hopefully will be an upgrade on my Ender 5 Plus build plate. The problem with the Ender 5 is that it's a massive build plate of, they say 350, but I've modified mine, so I think I can now print 380 by 380, and that's another video I need to do. Now this is interesting. I thought I was going to be a lots of bolts short, but if that's 100, now I didn't count them. I'm only 1, 2, 3, 4, 5 short, and that's terrible. That was bad planning, Andy. So I probably will change the design for you. I'll have to count them now because it'll just annoy me. And if I am five short of, well, that's 105. I'll mod this design, although it's pretty symmetrical like this. I'll mod it so you only need to buy 100 screws, because if you can only buy them in like batches of 100. I didn't see them in 50s, so yeah, that's a damn shame. But I do have another bag of these somewhere. Anyway, so that's that, and I mean, obviously it's heavy towards the front because there's more weight there. So my idea is this one is going to have the magnifying glass. Then you don't have to have all the others fitted. You can have either 2 or 4, depends what you're doing, but normally 2 arms are good enough. And I'm hoping that maybe just on the 2 ends here, so maybe the magnifying glass here. So the hardest thing about this print was getting these damn tops off, these orange tops, and they do pop off, but I did struggle. So what I ended up doing was got a mug full of boiling hot water, dipped the plastic in only up to almost the top of the orange so it got hot. Then I peeled it back like this, and then used my thumb, and I had to use some pressure and keep bending it, and it did pop off. Now I probably can't do this one dry. I'm going to try my damnedest, but you can feel it almost going, but it just won't go. So the hot water was, no, I can't do it. So it needs a hot water trick. So I've got 2, so I've done 2 already. So let me just screw these in. So these blue arms, they are, well, now to the top of the alligator clip, has 11 inches or 228 centimeters, or 28 centimeters. So you can see that you can quite easily like get a, I've got an Arduino sensor somewhere. So here's another project I'm working on. Don't miss this one. This is a great project. So I'm going to put some heat shrink on these teeth to protect what you're holding. Now I can just hold it on the corner there because there's no let's do it on both corners because there's no circuit board under there, so I know I haven't got the heat shrink on. But that now just gives you a stable platform, and by the time you've got a magnifying glass in the back coming up on this pole, it'll be great. So obviously these can come down lower. So that's it. I mean, I enjoyed doing this project because it's my first print on my new printer. I'll show you it completed once I've got the magnifying glass. I don't think I will put on more arms. I think 2 is enough. I mean, if you're doing a big circuit board, possibly you'll need 4 to hold it. So that's the idea of putting the holes in. Now if you were really concerned, you could, well, maybe I will, you could try 3D printing a cap to screw in here to make it look nicer. But yeah, what do you think? I mean, say it's not a, you know, it's not a brand new design, there's lots of these, but this is my take on the design. The STL files will be in the link in the description. Do the test prints first to tune in your printer. You may have to play around with the threads depending how your printer's set up. This was printed with GTD 3D PLA plus fluorescent orange, printed on a standard Ender 5 3D printer. Say standard. The only modification I made on it is the Luke Hatfield hot air mod, which isn't necessary to print this project. It just makes it easier maintenance, and you don't ruin a whole Bowden tube. But if you've got one of them printers, you'll probably know about it. So if anyone's interested, the maximum distance that I can get between the alligator clips is 170 millimeters, or just under 7 inches. So between the ends of the blue arms is 25 centimeters or 10 inches. So that's plenty of room. See, look, I can get my fist in there, and if I spread my fingers, you know, a good, say, 6 inches. So I think that would be fine. And I think what I will be using it more down here, and then by the time you get the magnifying glass attached to that, that will give you a good working platform to work from. A lot easier when your things you're soldering not moving and they're not pushed in plasticine or blue tack. Yeah, tell me what you think. Interesting project. But next time I use, well, next time I say when I use this for the first time, when I've got my magnifying glass on, I will post a picture of it completed. But yeah, that's Andy feeling happy with himself and wishing you a good afternoon.